Okay, let's look at the midterm. And we're going to, this will be like a review. So we've covered chapters 3, dealing with the graphing and the functions. And then chapter 4, dealing with the systems of equations. And then you have chapter 5, 8. 8 is a review of just equations and inequalities. All right, so let's look at some problems on the midterm. Your midterm, you have 20 questions. All right, so we'll look at it and let's see. We have to write an equation in slope-intercept form. And so make sure you have a formula sheet, with the formulas on it. So here, let's go through some problems. You have to write an equation in slope-intercept form. So first of all, what's the slope-intercept form? The slope-intercept form is y is equal to mx plus b. That's the slope-intercept form, where m is your slope and b is your y-intercept. So it says write an equation in this form of the line passing through the given point and having the given slope. So here we have the slope and we have a point. All right, so, but we need to put it in this form. So let's fill in what we have. We have an x, and we have a y, and we have m. So if we have x, y, and m, we can use the slope-intercept form to find b. So let's substitute. So we have 6 is equal to 6, and x is times, this mx means times, so times 7 plus b. So we have an equation to solve. Let's simplify. 6 times 7 is 42 plus b, and then solve for b. All right, so that means you're going to subtract 42 from both sides, and then b will be equal to a negative 36. So we have b. So when we write this equation, we just need to know m and b. So we have m is 6, and b is negative 36. So therefore, the equation in slope-intercept form will be y is equal to 6x minus 36. All right, so x and y are arbitrary, so you leave those alone, okay? So y is equal to 6x minus 36. That's your equation in slope-intercept form. This one here, you're just solving this, okay? So when you have a fraction, let me just show you different ways of solving it. So you have 3/7 x is equal to 8. We can actually make 8 into a fraction, put that over 1, and so we have a proportion, and the x really is at the top, okay? So when you see x on the side, it's really at the top. So we can write it as 3x over 7 is equal to 8 over 1. And then you can cross multiply. This is when you use the word cross multiply, when you have a proportion, when you have an equal sign in the middle. And so we multiply these two and then multiply these two, set them equal. So we have 3x times 1 is equal to 8 times 7. So no fraction. So 3x times 1 is just 3x, and 8 times 7, we have 56, okay? And then here, just to, solve for x, how do you solve for x? They're not asking you to solve either. All right, so we're just solving it. Let's solve, okay? So I guess it may be good to read the directions. All right, and so x would be equal to 56 over 3. But what they're asking us is to what number must be multiplied on both sides in order to isolate the x on the left side of the equation. So in this case, okay, to get the x, if we have 3/7 x is equal to 8, to get the x by itself, then you would just multiply by the reciprocal. So multiply by 7 over 3. And that will eliminate that, okay? So that's all they're asking you to do. But if you actually had to solve it, you can do it this way by multiplying both sides by the reciprocal, okay? And see, you'll get the same thing, 56 over 3. or you can set it up as a proportion. All right. So they just ask you to solve it. They just ask you what number must be multiplied by both sides. Okay. So to get rid of this 3 7s, you multiply by the reciprocal, which is you flip it, 7 over 3. Because 7 over 3 times 3 over 7, they cancel. They just gives you 1. Good. And then you're at, you have equations to solve. So you're just looking at it. Okay. So make sure when you're putting in your answer that you do not write y equals. Okay. Just put it as a solution set. Just write the answer. Just write the answer in the solution in the set. All right, so when we're dealing with unions and intersections, so it's important to know, okay, the symbols here. So union, that means union. That's all together, means all together. Think about your family reunion, okay, your mama's side and your dad's side, all together. And then the intersection, what's common, okay? What's common? All right, so here you have set A has the elements 5, 6, 7, 8, 9, 10, and then B has elements 7, 9, 10. And they want to know what the union of A and B is. So that means everything, everybody. So that would include A, which also includes B. So 5, 6, 7, 8, 9, and 10. That's your union, okay? Now, what if you were asked to find the intersection of A and B? So if you wanted to find the intersection of A and B, we have to see what they have in common. So they have 7 in common, 9 in common, and 10. So that set will have 7, 9, and 10. Okay? So that's dealing with the union and the intersection. All right, so we're dealing with the, this is from chapter 4, dealing with the elimination. Notice here that this is already set up. If you want to eliminate, it's already set up where the y's eliminate. So if you add the two equations and one of the variables eliminates, you're good to go. If they don't, you have to kind of manipulate it to eliminate one of the variables. So here, if you add them, the y's cancel. This gives you 4x is equal to 12, right? And then solve for x, divide by 4, you get x is equal to 3. So once we have a value, then we can plug it into either original equation. So it looks like I would use the second one, okay? X plus y is equal to 4. I know x is 3, so that means 3 plus 1 is equal to 4. So when you write your solution set, you're writing your ordered pair. So you make sure you put your ordered pair inside the brackets here. So that means that these are intersecting lines because we have a solution. Okay. All right. Here you're finding the equation, slope and y-intercept form. All right. So find the equation. So write the equation of the line with the following slope and y-intercept. So you just use the, you're given the y-intercept, you're given b and you're given m. So that's why you have y is equal to 8x minus 5. Again, we have another equation to solve. Again, when you're dealing with these fractions, an easier way to do is to eliminate the fractions. So look at your denominators, 6, 5, and 10, and find the least common multiple of 6, 5, and 10. Okay, so if you look at 6, 5, and 10, what number will 6, 5, and 10 go into? What's the lowest number that 6, 5, and 10 will go into? 30. Okay, so multiply everybody by 30 over 1, including the 4. Okay, and then solve for x. So that's your way of dealing with that. But let's look at that real quick then. Just make sure you know that. So the LCM is 30. Okay, because we want to. You can deal with the fractions if you want to add, subtract, work with the fractions, that's fine. Some people don't like to deal with it. So we're going to multiply each one by 30. Including the 4. Some people forget about the 4. So every term has to be multiplied by 30 over 1. All right, so let's simplify. Okay, so 6 will go into 30 5 times, and then 5 times 5 is 25, so that's 25x. Then 5 will go into 36 times, so that's minus 6x. And then we got this big number, 120. And then 10 will go into 30, right? So it goes to itself 1 time, it goes in that 3 times, so that's 21x. So you don't have any fractions, okay? So now, all right, so now you have 25 minus your 6x, right? So you get what, 19x plus 120 is equal to 21x. All right, so now move your variables on the same side. So I choose to move the 19x over to the right. You do the opposite, so minus 19x minus 19x. Okay, I have a 120 is equal to 2x, and then divide by 2. So 60 is equal to x. And again, you just put it the 60. Don't write x equals 60. It's going to count you wrong. All right, again, this is matching your equations with your graph. Now look, be able to describe, you have, your positive slopes and negative slopes. So this is going down. That's a negative slope. This and this A and B, well, this top one and A and D. A and D are negative slopes. And then B and C are positive slopes. So right away, you can eliminate the equations. Okay, so you know that this A and B have negative slopes. C and D here have positive slopes. And then you have your intercepts. This is a positive 6. This is a negative 6. So this is how you get, for example, y equals negative x plus 6. That's a negative slope. So that's between A and D, right? And then the y-intercept is at 6. So that would be A. So that's what you do. And so each one, just kind of analyze it and rationalize it. Okay, again, you're solving equations, right? Solving equations, not going away. The ordered pair, this should be the easiest question. The ordered pair blank negative 5 is a solution of the equation x equals 5. So if it says x equals 5, there's no y, it means x equals 5. So the x coordinate will always be 5. So this is a vertical line. When you have x equal to a constant, that creates a vertical line. More equations to solve. Finding the slope. So again, make sure you have your slope formula by you. So the slope is y2 minus y1 over x2 minus x1, or rise over run. Okay, you can graph it, plot your points, and do rise over run if you want to. Or just use the formula. Just make sure you be careful with your signs. And then you can label this x1, y1, first point, x2, y2 for your second point, and just plug it in. And let's plug it in then. So we have negative 19 minus, negative 10. So you got to be careful. So minus a negative. And then on the bottom, you have negative 13 minus a negative 3. So you got to be careful with those negative signs. Negative of negative becomes positive, right? So that's plus and that's plus. So we have negative 19 plus 10 on top and negative 13 plus 3 on the bottom. And so at the top, we get what? Negative 9. And at the bottom, we get what? Negative 10, right? And then we have a negative of a negative. So that creates a positive slope. So you got to be careful with your sign numbers. All right, so dealing with your inequalities. So that's coming from chapter 8. So just remember, if you multiply or divide by a negative, it reverses the inequality symbol. And so also remember that if you have less than or greater than, that's going to be open brackets. Okay. If you have less than equal to, greater than equal to, that's going to be your closed brackets. All right. And so remember, if you multiply or divide by negative on both sides, you reverse the inequality symbol. So this is a good one. Negative 2x less than or equal to 4. To solve for this, you divide by negative 2. So I divided by negative, right? So x, reverse the inequality symbol, is greater than or equal to negative 2. So the question is, it's good if you graph it first before you write your solution set. All right, and so this is x is greater than negative 2, right? X is greater than or equal to negative 2. So greater than or equal to negative 2 means inclusive, right? So what numbers are greater than or equal to negative 2? So we'll be at negative 2, or all of these are at negative 2, okay? So it'll be closed. So we can cross this out and cross this out because we know it's inclusive, correct? So now what's greater than or equal to negative 2? So that means I'm going to the right. So here, going this way. That's greater than or equal to negative 2. You see that? So now, if I want to write my integral notation, it's really staring right at you from the graph. So we'll be closed at negative 2, and that's going all the way to positive infinity. And you cannot close positive infinity or negative infinity. So this is your integral notation right here. Here, they're asking you to graph the intersection. Now, so we talked about the intersection, right? Intersection is just what they have in common. What's common? So if we have this graph and we have this graph, okay? So what's common? So what's common is here to here. So with open, so open, okay? So this is what common, not including the -7 or the +1. So, all right, and so we'll have open brackets at that. So that's why C is the answer. And that's just asking for the intersection, what they have in common. Now, if they ask you for the union, that means all of it. So that means I would have the whole line. The whole line would be shaded, okay? The whole line from negative infinity to positive infinity if it was the union, okay? Include everybody. All right, find the slope of the line. So I gave you ways of finding the slope. And so one of those ways here, so if you put it in the slope y-intercept form, you can identify the slope. Here, if you saw, most of you will probably solve for y. To solve for y, you divide each one by 5. And so we have y is equal to 1/5 x plus 2. So m is equal to the 1/5. That's the slope. The y-intercept is 2. All right, so you complete this ordered pair. It's giving you the y value, plug it in and solve for x. Again, we have a elimination problem. So here, let's look at this one real quick. This one is not as easy as the last one because you can't just add these. Nobody eliminates. You have to eliminate in order to solve for one. So with the elimination method, decide which one you want to eliminate. So in this case, we have a 1y here and a -3y here. The signs are already different, so you don't have to worry about the, multiply by negative. So the least common multiple of 1 and 3 would just be 3, right? So the object is to get a 3 and a -3 in the position. So I already have a -3, so I need to get a 3 in this position. So what do I need to multiply by to get a 3 in this position? Multiply by 3. There you go. You got to multiply everybody though. Okay, so if I multiply everybody, you get 15x plus 3y is equal to -33. And then just rewrite the second one. We don't have to really change that, multiplying it by 1, because we already have a -3 in that position. All right, so now you can add. So we had to do a step prior to adding, subtracting. So the y's cancel. You add this, you get what? 22x is equal to, you add this, you get negative what? 66. And then now you can solve for x. Divide by 22. So x is equal to -3. Okay. And so once we have a value for x, then you can plug it back into either original equation to find the value of y, which should come out to be 4. So you plug it in. So 5 times -3 plus y is equal to -11. So -15 plus y is equal to -11. And then add 15. So we get y is equal to 4. So that's the ordered pair, -3, x first, and then y, 4. So you got to make sure you put it in as an ordered pair. Okay. Find the solution. Dealing with absolute values, you have two outcomes. Here, you would add 2 to both sides. So you get absolute value is equal to 8. So what values will give you, what x values will give you that solution? So absolute values is dealing with the distance. So the absolute value, so when you're dealing with that, okay, so let me just, when you have the absolute value equal to a constant, then your two equations are x is equal to plus or minus c. So in this case, you have the absolute value is equal to 8, right? So that means that x is equal to 8 or x is equal to -8. So that's why they have and separated by a comma. Right. Same thing if it had been like the absolute value of x plus 1 minus 2 equals 6. I still will go through the same process, add 2 to both sides, but this time I would have absolute value of x plus 1 is equal to 8. I still would have two equations. First would be x plus 1 equals 8, or x plus 1 is equal to -8. And then I would have to solve those. It wouldn't be as easy as the top. So solve this one, so subtract 1, x equals 7, subtract 1, x equals -9. Okay? And then in your solution set for this one will be 7, -9. Good. Just wanted to throw that out there. And then you have your word problem. So we kind of did this one in a different video. So setting it up and then using your system, strategies for solving systems of equations. And then inequality. So, and I kind of give you the rules for the absolute value inequalities because it's like a compound. So if you have the absolute value of x is greater than or equal to 3, then this would be an or. So it would be x greater than 3 or x is less than -3. Okay, in this case. And so, yeah, it's not, yeah, this is an or statement when it's greater than. If it had been absolute value of x is less than 3, then it creates an and or intersection. So it'll be -3, x is between -3 and 3, okay? All right, so we're dealing with this. So x is greater than 3 or x is less than 3. This is an or, so this is a union, okay? This is a union. So if we look at this first one, x is greater than 3. Let's put 3 here. This is open. Open at 3, greater going that way. And then x is less than -3 would be, let's see, if we have -3, less than, so x is less than -3. So here, open, and then these are less than. So if you notice here, it would be better to put this on the left and this on the right so you can actually see it. So, oh, this is equal to, so it's, yeah, okay, it's greater than or equal to, so it'll be closed bracket. I was thinking that it wasn't, so it's closed. Close, so it would pick this one. Okay, this is representing the x is less than or equal to -3. This one's x greater than 3. This is a union. And so when I write this, okay, this is to the left, it's going, the lowest is -infinity. So -infinity to 3, -3, and that's closed. And then union, and then write the interval notation for this one. It's closed at 3, and it goes all the way to positive infinity, open. So that's how you're doing that. All right, so just make sure, yeah, this is a close because it's equal to, and so that should be closed bracket. And then you can just do this on really one line, okay? Put -3 here and 3 here if you really do it that way. So it would go this way, and then this will go this way. All right, good. So hopefully you do well on it. If you have any questions, please let me know.